Hey guys, just wanted to do a short video on the wheel. Gonna get ready to tear a bunch of stuff down and change a few things. I wanted to document the consumption rate and the pull force while the coils are engaged before I add the other coils, so we can see the differences in the improvement. So current input is going to be 35 volt. No inverter, no power supply, straight off the batteries. This is the amp draw on the entire system. The current RPMs, nothing super impressive, but we are running the physical load too. Now this is an older style fan. It doesn't have a bearing. It's got the old cotton and oil shaft. I'm currently just throwing the back EMF away. I'm gonna stop the wheel now and then we'll get a full force thing on the coils while they're engaged. So currently, do I have it on the right side? In pounds, I'm just gonna pull the fucking thing back. Right here is the coils engaged. I don't fire my coils till the magnets get to here. So we are at almost 4 pounds of pull on the outside. So while the coils are engaged, there's 4 pounds. Naturally, at this state on the wheel, there is roughly a pound of pull between just the core before it energizes. So when it gets to this point, the coils energize, there's 4 pounds. So you would multiply that by the 24 inches. It's a wiring nightmare. So I want to change a few things. Like I said, I'm throwing the back EMF away. I think I'm going to add, this is the first cycle. I think we're going to add a second cycle over here in the same fashion. I'm running 2 coils paralleled, or 2 coils in series here. And then this third one is actually the bucking configuration, still in series. So when I pulse it, I am either getting 2 norths and a south, or 2 souths and a north. I've got a concept that the pitchfork looking coil allows the flux to switch a little better inside the cores. Right now I'm not using the generator coils, but having them next to the driver coils, it kind of plays the pass of the long game for the attraction on the coils when it's in the off mode. If I add a second cycle, that'll extend that. If I wanted a third cycle, here I would need to go with an air core. Otherwise, I would cancel all the natural attraction that I had with the magnets to the first coil. But anyways, it's a long enough video. I want to document the consumption rate while carrying the load. I can get it lower, but the switches act a little funny. Still running the mechanical switch with a big ton of Neos on it. I do want to try to incorporate the crankshaft sensing pulley off of the pulse assisted wind turbine project. See if I can get the wheel to function with that. See the differences in the consumption rate between going with a transistor versus a mechanical switch. I will say right now that the contact that your switch makes, when it makes the contact and then breaks the contact, makes the huge difference on the consumption rate of your motors. If your switch doesn't fire correctly, you could actually cause your motor to use more power than it has to. And these things will use whatever power you give them. So that clean connection and the clean break is very important. Nikola Tesla even says a spark is wasted electricity. Currently, I'm getting no spark on the switch at the 36 volt. I'm going to tear her down, add some more coils. We'll see where the torque changes from the 4 pounds energized. We'll see how low we can keep it with increasing the torque on the shaft. Well, thanks for watching. Give me a thumbs up if you guys are liking it. I'm going to break out the wind turbine again here this weekend and see if we can get it running better with the 6 pulses. I'll have it going.